Okay, kids, we're going to continue on with the polar fun. And just as a warm-up here, let's plot the coordinates that are in polar form. -6, 5 pi over 6. Remember, this is your r, this is your theta. And there's two ways to think about it. You can either think about the angle first, which is 5 pi over 6, which would put you right along this line, but then going -6. So instead of going 6 units out, 6 units back. 1, 2, 3, 4, 5, 6. That'll put you right there. Or you could think of it like doing the r value first, going 6 to the left. 1, 2, 3, 4, 5, 6. And then going 5 pi over 6 in the positive direction from there, putting you right there. Either way, same spot. But what we're doing today is converting from polar form to rectangular form and vice versa. So let's just think about how you could do this without any special formula. I mean, you're going to see these formulas, but the more you remember where they come from, the less it seems like memorizing, and the more you just understand it. This radius, that distance I went out, is a distance of 6. I always think of that as distance being a positive quantity. And the idea here is, how do I get to the same point in rectangular form? So using x and y. And x and y is all about left, right, up, down, traditional Cartesian plane, movement. So how do I get to this point? Well, that would be going straight to the right a certain amount and then straight down a certain amount. This is your x and this is your y. And the key is all in that angle and the radius that we have there. If that is 5 pi over 6, that means my reference angle is pi over 6, or 30 degrees. And now we're just looking at a 30, 60, 90, like all of these trig things this year. They've come down to those special right triangles. And if your hypotenuse is 6, that means the short leg, or the side across from 30, will be half of that. It will be 3. And your x value would be the long leg, or across from 60. That would be 3 root 3. Remember your relationship of, x, 2x, x root 3, where the short leg is half the hypotenuse, and the long leg is the short leg times root 3. And so those rectangular coordinates would be 3 root 3 to the right, and then 3 units down, so -3. So really not too difficult, and we didn't even need special formulas. But if you want to see the formulas, because you'll run into them, it's nice to know where they come from and not be too scared off by the formality of them. That, remember, for any point here, x, y, you're really just talking about a right triangle where your theta and your r are going to dictate these dimensions. And the sine of theta is always equal to y over r, right? That was that relationship we've seen again and again this year. And the cosine of theta is always that adjacent, or x value, over r. So when it comes time to convert here, if you have r and theta, really x is always going to be just a manipulation of this. That would just be r times cosine of theta, right? Just taking this equation, multiplying by r. The y value would always just be a manipulation of this, which is r sine of theta. So you really could do this without a picture. If you had r and theta and you wanted the x coordinate, you could just plug into this formula. Boom. R times cosine theta. Y will be r sine of theta. And that's that. If you're going the other way around, if you have the rectangular coordinates, you have x and y, and you're trying to convert to polar form, well, you need the r and you need the theta. How do you get r if you have x and y? Well, that's just keeping in mind this relationship. X squared plus y squared equals r squared. That's your Pythagorean theorem there. We also use that to find the modulus, or the absolute value of the complex numbers we've been talking about. And so r would be the square root of that. The tangent of theta, again, this is how do I find theta purely in terms of x and y. The tangent of theta would be y over x. Same relationship we've seen, and that means theta is going to be the inverse tangent of that. You do have to be careful with what quadrant you're talking about, and we'll see some examples here. So, number one, I don't really care how you do these. I kind of like both ways, but I like to draw the diagram at least at the beginning until you're super comfortable with this connection of what you're doing. You have a point that's in polar form. Let's convert it to rectangular form. So I'm actually going to draw the sketch, but remember, all you're really looking for are two things when all is said and done: r and theta. X and y in this case. I have r and theta. Whoops. I'll leave that right in though. Not doing this video all over for that. Negative 3 pi over 4. I'm just going to do a rough sketch here. My theta being 3 pi over 4 would be in quadrant 2, and then going negative 3 would put me 3 units backwards, or 3 to the left, and then 3 pi over 4 from there would put you right about here. That hypotenuse, or that radius, would be 3, and since this angle was 3 pi over 4, my reference angle is pi over 4, or 45 degrees. What's your x and what's your y? Well, again, it's going to come down to one of those 45, 45, 90s, or 30, 60, 90s. If that's 45 and that's 45, these are the same amount. If the hypotenuse is 3, you divide both sides and you get 3 root 2 over 2, right? You divide that hypotenuse by root 2. So we get 3 root 2 over 2. And your coordinates, your x value is going to be positive because you're to the right. Your y coordinate is going to be negative. But if you like the formula, just so you see how that could work, x is r cosine of theta. You could just do this right off the top of the bat here without even a diagram. R is negative 3 cosine of 3 pi over 4. Hopefully those unit circle values aren't too rusty, and you get cosine of 3 pi over 4 is negative root 2 over 2. So that when you multiply that, you actually get positive 3 root 2 over 2. That's your x value, and your y value is r sine, so negative 3 sine of 3 pi over 4. That's negative 3, and sine of 3 pi over 4. 3 pi over 4 is in quadrant 2, so sine will be positive. So you actually get negative 3 root 2 over 2. Same thing we got. Doesn't matter to me how you get there. I like to do both just to make sure you have an x and y value. If you're sure with your graphing, we know we're in quadrant 4. This should be positive, this should be negative. If you make a silly trig, mistake here and maybe make that positive or negative, you get a little confused. You might not ever really catch yourself unless you thought of what quadrant you're supposed to be in. So for the time being, I would recommend doing both. And it's a good practice for plotting your polar points, which are still fairly new. Negative 4, 3 pi over 2. Again, you could do r sine of theta and r cosine of theta. Negative 4, 3 pi over 2, 3 pi over 2. If you do the angle first, that's here, and then go 4 units backward, it's going to put you right there. Or negative 4 to the left, and then 3 pi over 2 from there is going to put you right there. Do you really need any special formulas to know the coordinates of these points? If you're 4 units straight up, that's just 0, 4. There's your answer. If you really, really want to do it, of course, x is r cosine of theta, right? X is always associated with cosine. Cosine of any of the pi over 2's is 0. Boom, 0. Y is negative 4 sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1, and so that actually gives you positive 4. 0, 4. Doesn't matter to me. All right, let's just do some the other way around. Now we're in rectangular form, so these are x and y values, and we want to find one set of polar coordinates. Remember, with polar coordinates, because of coterminal angles and the like, there's actually an infinite amount of answers you could give me that are correct. So just got to give me 1. One thing that is helpful is to realize 4, negative 4. You are definitely in quadrant 4. 4, negative 4. I'm going to really do it just by using the triangle, 4 to the right and 4 down, because to me, if you realize you have that, you should instantly recognize what kind of triangle is this. Oh, the legs are congruent. That's a 45, 45, 90 triangle, so that's pi over 4. The hypotenuse is going to be x root 2, 4, 4, 4 root 2. And guess what? You pretty much have what you need right now. Your r value is 4 root 2. That's the hypotenuse. Your theta value, you could say a few things. One is kind of like we've been doing all year, going from standard form. If this is positive 4 root 2, and that's pi over 4, then that rest of the angle is 7 pi over 4. You also could do 4 root 2 negative pi over 4 if you want to get to that same spot with the short way. You could also mess around and give me a negative r value and a different theta, but these are all perfectly good examples. If you're a person who likes to stick with the formulas, then that's fine too, of course. R squared is the square root of 4 squared plus negative 4 squared, and that of course is 16 plus 16, which is 32, when you take the square root to get r, of course, and that reduces to 4 root 2. And then your theta, if you start with tangent of theta, is y over x. Y over x is negative 4 over 4, and that is negative 1. When does tangent equal negative 1? Just be careful here. Tangent is 1 or negative 1 when the reference angle is pi over 4, and it's negative in quadrants 2 and 4. So you still have to put a little thought in here and say, well, if we're talking quadrant 4, because that's where this rectangular point most certainly is, then we'll use the quadrant 4 version of pi over 4, which is 7 pi over 4. So however you get there. So a couple others to wrap this up here. Negative 5 root 3, negative 5. What quadrant are we in? We're in quadrant 3. Negative 5 root 3, negative 5. To me, I look at that right triangle and I see that's 5 root 3. This is 30 degrees right here, or pi over 6. And that means that hypotenuse is going to be 10, right? Double whatever that short leg is. So to me, maybe I just love geometry, I don't know. But the r value is 10, and what is the pi over 6 in quadrant 3? 7 pi over 6. Boom. You want to use the formulas? Go for it. All good, as long as you get to there. 0, negative 3. 0, negative 3, especially when you've got a quadrantal situation here. Don't make it harder than it has to be. 0, negative 3 is right there. Your r value is 3. You're 3 units away there. And your theta, if you're right here, your theta value could be 3 pi over 2 if you're looking to give an answer between 0 and 2 pi. You also could give 3 negative pi over 2. You also, if you wanted, just for fun, if you wanted to use a negative r value, that could be negative 3 and then go pi over 2 in the positive direction. So you could have something like that. I mean, you could go on and on. The fun doesn't have to stop. So there's something to do for you to do on Saturday nights, kids. Just keep making different coordinates. And 0, 0 at the origin, or in other words, at the pole, as they call it in polar form, like as in like the North Pole. If you were looking at the top of a globe, that's where the North Pole would be. So the origin they call the pole. What are the coordinates there? Well, if you're here, the r value has to be 0. the theta value really could be anything you want. So I'll just put 0. I'll put pi. I'll put pi over 6. 17 pi over 13. It doesn't really matter if you're talking rotational, because as long as r is 0, you're there at the pole. So really it could be 0 comma anything, just so you know. I don't know why, I just like pi over 6. It's a great number. But okay, hopefully that wasn't too painful, and if you have any questions, just feel free to ask, and I'm right here, so take it easy everybody. Hope all is well.